Okay, so chapter 10, probability, data analysis, and discrete math. I don't think that you guys have seen this kind of branch of math and this type of thinking, but this is like my favorite branch of math. I really enjoy it. So you'll see it. Guys, you're being really loud. And it's only half of you. Okay, so I really like discrete math and probability. It was my favorite class in college. And I'll try to make it really interactive so that you guys can enjoy it as well. I think it's very applicable, more applicable maybe than graphing. Okay, so section 1 is titled Apply the Counting Principle and Permutations. You might have never heard of that word before, permutations, but we'll learn what that is, possibly tomorrow, maybe not today. But today we'll learn about applying the counting principle. Now, obviously, everybody knows how to count here, but the idea behind the counting principle is to count the number of variations of different things. Are you good?
Yeah, I just needed a pen.
Pen or pencil? You don't have either?
I lost it.
Make sure you come prepared to class with pen and pencil. Okay, so the counting principle, when is it useful? So sometimes in life you have to count the number of different possible options available to you based on different variations of whatever product. So how do we figure out how many options we have? We have to use the fundamental counting principle. So what is an example? Let's say you're trying to buy a snowboard and you have different types of boards and different types of boots. So in this example, guys, I know you haven't had class all day and you're probably just talking and relaxing, but you're having class today in this class. So stop talking. Okay, so there are 3 types of snowboards. You have all mountain, freestyle, and carving. So typically whenever, does anybody snowboard here? Or has anybody snowboarded? Yeah? Big Bear. Do you rent or do you own?
I rent.
Okay, so for the different types of snowboards, you have all mountain, which is kind of like a very neutral, you can go anywhere. It's not specialized in any I guess any type of terrain. And they have a freestyle, which is typically whenever you want to jump or whenever you want to go on boxes or rails. You have freestyle. Those are typically a little bit shorter and more symmetrical, so that if you do like a 180, you can land on the other side and it's exactly the same board. And then you have the carving ones. Those are typically a little bit wider. That's so you have a little bit more surface area whenever you're carving on deep snow. And they're directional, so the front of the board is different than the back of the board. Depending on your writing style, you might want to pick one of those 3. And then they have 2 types of boots. You have a soft boot and a hybrid boot. Whatever that means, doesn't really matter. You just have 2 types of boots. So, how many choices does the store offer for snowboarding equipment, right? You can pick whatever board you want, and you can pick whatever boot you want, depending on your style of riding. So how many different possible options do we have in total? Does everybody understand the question?
Yes.
Right?
Yes,
You can
yes.
pick a board and you can pick a boot. How many different options of boards with boots are there?
5.
So the idea here is you pick your board first. So you have one of 3 choices, right? All mountain, freestyle, or carving. And then for whatever board that you picked, you also have different options for boots. So for all mountain, you can choose soft or hybrid. For freestyle, you can choose soft or hybrid. And for carving, you can choose soft or hybrid.
Son combinaciones, se puede decir.
Right, you have different combinations depending on whatever options are presented to you. So in total, you have 6 different combinations. You can do all mountain soft, all mountain hybrid. Freestyle soft, freestyle hybrid. Carving soft, carving hybrid, right? And so our total number of options is 6. But imagine if there were like 15 different options of boards and 10 different options of boots.
150 combinations.
How did you get 150?
I multiplied both of the variables.
Right. And so that's the counting principle exactly. Now, for those of you who haven't like, it hasn't clicked yet, whatever he said, obviously we don't want to do this huge tree if we have 10 here and 15 here, right? Or if we have more options, for example, let's say you could pick like the board type, the boot type, and let's say you could also pick maybe like the wax. The wax underneath is really important, and there's different types of wax. What if they gave you another option? Like we have 7 types of waxes. How many different variations do we have now, right? And so the idea is that for each number of variations that you have for each category, you can pick, you have 3 boards, 2 boots, and let's say 7 wax. For each of those, you multiply all of your options, and that gives you your total number of variations.
So would it be 2 times 3 times 7?
2 times 3 times 7, yes, in that case. Well, yeah, 2 times 3 times 7.
There were
yeah.
7 different types of waxes.
Yeah.
So you would multiply the amount of boards times the amount. No, type times the types of boots times the type of waxes.
Yes. So before we go into the counting principle, why don't we just use that little tree all the time? Well, it's not scalable, and it's going to take us a long time to do that little tree if we have a lot of different options, right? You can think of scenarios where you can pick like 10 different categories, right? Let's say like a house, right? It can be, you can like change the roof, change the front door, change the garage, there's so many different variations. And within those categories, there's like 15 roofs, 100 different doors. You wouldn't want to do a giant tree and try to count it out. So the easiest way to do it is to use the counting principle. Now, what the counting principle tells you is that whenever you're trying to find the number of variations of something, you pick all of its characteristics and you multiply the number of options for each characteristic that you have, and that'll give you, when you multiply all those together, that will give you the total number of variations. Who's outside? Where are you waving to?
Yo?
No, Andrea. She keeps waving and looking outside.
Estoy Valencia.
Okay, just don't look outside.
¿Por qué no lo entiendes, Stefan?
Write notes or
Y
something.
habla español.
Spanish.
Me trae tu ira, pero lo tomaré después.
Okay, so if you the most, I guess the simplest scenario is if you only have two different events, that's what they call it, I guess, in math. Because obviously if you only have one event, one variation, well, that's just it. That's the number of variations that you have. If you can only pick a board and we have 10 different boards, how many boards can you pick? Just 10, right? But once you add another characteristic like the number of boots, then we can combine all of those and we have a much bigger number. And so what this says is if one event can occur m ways, whatever m is, m can be any number, and another event can occur n ways, so a different number of times, then the number of ways that both events can occur is m times n. In our case, we have boards, we have 3 different ones, and boots, we have 2 different ones. So our total, based on the fundamental counting principle, our total options is 3 times 2, which is equal to 6, which is what we got in this little tree.
That's
right?
really useful.
That is really useful. Okay, when you have more characteristics different, like now instead of just boards and boots, you can specify, for example, wax. And let's say we had, as we said before, 7 different types of wax, then our answer would be
42.
3 times 2 times 7,
42.
which equals 42. 42 different options. We don't have to draw the tree, we don't have to draw any of that. Just based on knowing for different characteristics how many options we have, we can figure out like the total possible combinations. So yeah, sometimes on some websites, like if they're selling stuff, sometimes it'll be like, oh, we sell like 15,572 whatever products, and it's just like, oh well, actually it's just the same product with different combinations of colors and whatever sizes, colors.
Amazon.
Okay, auto-generated NFTs.
Banda.
So whenever these
One question. NFT is the abbreviation for Non-fungible what?
Tokens.
Token.
¿Usted tiene uno? ¿De seguro y seguro?
Uh-uh.
¿No? Ah.
También tonto.
Okay, so
Sí, no.
all of these are auto-generated, so whenever you mint them, they just randomly, well, it's not completely random, but based on some algorithm, it picks a background color, eyes, mouth, blah, 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 and then it just shows you what the product was, right? Like, it's kind of random in a way. How can we calculate the total number of different NFTs? Let's just stick with this one, the Bored Ape. How can we calculate the total number of different NFTs that are possible? Like the different options, yes.
Like form.
So background,
Okay, so background is the first option.
Background, lentes, la ropa.
accessories, color of the ape,
So, what do you mean by color of the ape? The skin?
skin.
Okay,
There's
skin
black
is
and
another
brown
one.
apes. There's gray apes too.
Okay, what else? What are my other variations?
Accessories.
Accessories, okay.
Clothes,
Clothes.
or maybe a skin.
I think because for example we have this skin, this guy also has the same skin but has a shirt on. So those are different variations. So we have skin and clothes, that's different. What else?
The mouth.
The mouth is different.
Mouth.
The eyes.
The eyes are different.
And that's it.
The tongue.
No, the
I think that's part of the mouth.
Yeah.
I think that's part of the mouth. And then we could also like go more granular. We could go like accessories of the mouth because for example we see that the cigarette is different than the glasses. So like glasses is another one.
That goes in accessories, right?
Well, how it depends on how these are generated.
Or maybe we can eliminate accessories and put glasses and hats.
Right, hat is another one.
Pero pues quita accessories y ponle que lentes.
Right. It depends on what you mean by accessory and it depends on how these are generated. But if, for example, let's assume that like everybody who has this earring piercing maybe also has like a nose piercing, then those would count as one because
Es lo mismo.
those are together.
Pero pues es que sería diferente, sería difícil porque no todos tienen lentes, entonces no se puede.
Right. So that's why they're different. You can have glasses or not have glasses, and that's independent. It's an independent event of the other
The
accessory,
smile?
right?
The smile.
I think it's part of the mouth.
Son
I think it's part of the
No,
mouth.
it's more.
But anyways,
En la boca, güey.
let's think of the number of. Let's just invent some random values. So how many different backgrounds do you think?
Poner 100.
20. Okay. Smaller numbers under 100. Skin.
30.
3. Hats.
30.
15. Clothes.
20.
10. Mouth.
4.
25.
4.
Pinche chuy.
Eyes.
5.
How many eyes? 2?
No.
Okay, it has 2 eyes, but how many variations of eyes do you want?
5.
Troleadísima.
Lo que quieras, lo que quieras.
7? 7 eyes? Okay. So 7 different types of eyes and glasses and then
Unos 40.
Ya, ¿cómo?
random number between 1 and 100.
Oh, okay, fine.
No me chistoso
Five.
chino.
Okay,
Sí, güey, súper.
without a calculator, try to guess how many different.
Sí, por favor.
Just think of it. How many different variations are there of this NFT? Assuming that we have these numbers. Because the real numbers are probably different.
700.
¿Qué dijimos?
No lo estoy diciendo. No te multiplica.
Out loud.
No, A ver, aguanta ya.
I'm gonna get. Okay.
Aguanta.
I have a guess.
Aguanta.
You guys came up with these numbers, so I don't know what the answer is.
30. Ok.
Ay, no. Ni para que gasto mi energía.
¿Cómo? No lo puedo hacer hasta que no seas tramposa.
Just
Como
eyeball.
20, 40.
Son muy grandes para
70.
Es que me da flojera multiplicar el 15.
Por favor. No, 85.
Es como que 60 por 15.
85 por 30, ¿cuánto es?
20.
Déjame acuerdo.
85 por 30, ¿cuánto es?
We're
A ver,
eyeballing.
80 por
We're not calculating.
80 por 30. Sería.
Okay.
Sería.
What's your guess? Final guess.
20,000.
20,000, 20K,
No, 20,000 no.
620K,
Sería como 1600.
1600,
No, like
okay.
6.
Sí.
Like 6,000.
6,000.
1600, sí. Está muy alto,
Ya estoy haciendo
20,000.
la
20
esta.
por 10, ¿no?
Oye.
200.
Por eso, bro.
No hagas trampa. ¿Qué?
Okay.
No, sí.
My guess is going to be 1 million.
¡Hola!
Ya, que chiquito.
Okay. I kind of cheated because we did this in the last class. Well, it was different numbers, and we actually came up with different. Like, variations.
1,600,000, cámbiale, Mr.
But like
1,600,000.
I guessed like I think it was like
Pues, güey, está
300,000 or something in the other one, and it came up to be
I got it.
like several
I got it.
million.
Ay, no hagas transero.
I got it.
1,260,000.
Yes,
Está más cerca, más cerca.
Pero me cae que haber más.
No. With these numbers, that's it. That is the total number. Now, in real life, maybe there are more backgrounds or less backgrounds. Maybe they have more different types of eyes. So it depends. You would have to know how many different variations of backgrounds, how many different variations of eyes, and so on, in order to calculate this number. But if we assume that it's exactly these numbers, then that's it. Now, what would happen?
Ay, es diferente.
Let me see. Let's say nose. Let's say I have two different types of noses.
2,000,004.
How would that change my answer?
Lo que salió.
Le cambia como por 200,000 casi.
It would double it, right? Because I had all of these options and it was like 1,200,000. And then at the end, I just multiply by 2. Remember that these all multiply together. So I already know what the multiplication of all of these were. And when I add another variation of nose, I just multiply by 2. Whatever that was. So it's like
1,260,000.
No. Es más.
1,200,000?
No, I got 2,520,000.
No, 1.5.
Pensé que era 2 punto algo, pero es un era 1 punto. Como 2 punto.
¿Cuántas
contraseñas hay de iPhone de 4 números?
There's next question.
Oh my god,
So,
Así son millones.
So-
Y son 10 números.
but
Bueno,
one second.
Es-
How many? Hold on.
De 4 dígitos.
De 4
So, in the first spot,
¿Sería 40?
Es
2,
factorial.
3, not yet,
Son 9.
but we will get there. That's permutations. So here, how many options do you have for your first number?
Son 10.
I have right 0,
Bueno, 10.
0, and then 1 through 9. So you have 10 options. How many options do you have here?
10.
10 options. How many?
40, ¿no? Ah, no, la cura, no.
Right, you have 10 options here, 10 options here, 10 options here, 10
Es que
options here.
multipliqué 4 por 10, ¿verdad?
So that's the thing. You're not multiplying by 4, you're multiplying all of these together.
Power of 4, pues.
Right, so 1 with 4 zeros.
10,000 combinations.
10,000 different combinations. And that makes sense because if you represent each of these passwords with a number, well, there's 10,000 numbers here, right? 0, 0, 0, 0, and then 1, 2, 3,
Yo el
4.
otro día vi un video de eso, pero con una baraja de cartas.
Yes,
Está más cabrón.
we'll talk about that later. This slide is the same thing that we did over here, just with different numbers. Okay. So, try yourself. How many different Tesla variations are there, assuming this information? Try yourself. Try yourself.
Sí, güey.
Ya lo había hecho.
Ya lo hizo. No había visto.
Oh yeah,
48.
yeah. It was 10,000.
Ah, pues es que le hice.
Aguanta, güey, que no lo grites.
Que no grite, número, pero.
A ver, ok.
Cállense.
Ok, sería.
Yo, mister.
¿No podemos con la calculadora?
Yeah.
Yo la tengo.
No se contaría como 1 o 2.
Performance or
Los-
basic models is.
Is that true, mister?
Somewhat, yes. It's a simplification.
Yes, I guess
Usted tuvo que
there's a
pasar
lot
por
more ways to
Entonces,
modify it.
usted tuvo que pasar por 96 combinaciones.
No, it's just estimation.
Es un ejemplo, güey.
Technically, no. Why? Because I already knew what model I wanted, and so all of the other models were discarded.
Oh, okay, you have to take that into
Ah,
account.
qué pro.
Sí.
Okay. How did you get? So Tinoco says 96. How did you get 96?
4 times 6 times 2.
So again, for each of your characteristics, you multiply the number of options you have for that characteristic. So you have 4 different models. What are the models? Do you know?
Six. No.
S, 3, X, Y. Those are the 4 different models
¿Cómo se
of
llama la
Tesla.
camiseta?
The X and the Y are the 2 SUVs.
Todo tiene algo.
La que cuesta $69,420.
¿Qué?
Sí, es una camioneta que cuesta eso.
Probably X.
No, es en serio, sí, sí.
Okay.
Elon Musk.
So you have the different models, and then once you pick your model, you have 6 different colors. They have like black, white, gray, blue, red, and silver. So you have 6 different colors. Now you can pick your interiors. It could be either black or white. The reason I said it was a simplification is because these are your options for the Model 3. I think the Model X and the Model S have actually 3 different interiors.
Oh, so
that would change.
Very nice.
But this is a simplification so that it's easier for us. And then your performance or your basic model. No, I have the 3.
Mister, I have a question. So how do you calculate when it only applies for the 3 and the Y?
We would have to add different things out of the scope for now. Don't worry about it for now. But you would have to add. So you would do like, how many combinations do I have for the S and the Y? If they all have the same number of combinations, and then add them for the X and the 3. Sorry, the
So
3 and the Y.
if the 3 and the Y had 3 colors, you would just add 2 more combinations. You would have 98.
Right, you would just have to calculate them separately and then add.
Yeah.
But yes. Okay, so how many different combinations? You multiply 4 times 6 times 2, right? Black or white interior. Times 2, performance or basic. And when you multiply all those numbers together, you get 96. You have 96 different combinations. Does everybody understand this?
Yes.
No, not really hard. If you understand the previous thing, you should be able to calculate A, no problem, especially with your question. B will require a little bit more thinking. You have to think a little bit more for B. So try doing A. A should be the same deal. So read the scenario, understand whatever the limitations that they put on the license plate.
¿Cuántas letras son?
26.
26.
26 letters in an alphabet.
No digits 1 through 9. No, 0 to 9.
Yeah. How many is that?
10. So it would be 26 times 10 times 26 times 26.
No me deja ni pensar.
Oye, está muy fácil.
Do B then.
How many?
No sé cómo hacerla.
Think about it.
Está difícil porque se repiten.
Ay, qué pro.
So A has no restrictions. You can repeat, it doesn't matter. But B, you can't repeat the same digit and you also can't repeat the same letter. So think, go go one space at a time and try to calculate how many options you have.
Es que no.
La B no me
Porque sí es.
Okay, so a license plate has, in Texas at least, has 6 spaces, right? So it has 6 different characteristics. It has something here, something here, something here, something here, something here, something here. So it has 6 different characteristics, and we have to count the number of options that we have in each space. That's how we'll get the total number of variations. So, in the first spot, Raul, how many options do I have? Let's do A first.
26.
I have 26 different options because the first spot has to be a letter, and there are 26 letters. So my first space has 26, second,
10.
third, fourth, fifth, and sixth. Okay, how many different options do I have for the second spot?
10.
I have 10 different options, 0 and then 1 through 9. I have 10 options. How many options do I have for number 3? 10 again, because it's another digit. What about 4th, 5th, and 6th? 26, 26, 26.
No sea tan difícil.
Okay, so because I have 26 options for the first spot, 10,
Eugenio, Elordi, José, Alejandro Coronado, Gloria, Renata Márquez, Max Escobar, Emilio Cárdenas, Daniel Arevalo, Diego Gallego, Ángel Abud, please report to the office.
45,697,600.
okay, so because we have 26 options in the first spot,
26,
20.
28.
26,
Daphne Borunda and Miguel Ángel Reynoso, also please report to the office.
we have 10 options for the second one, 10 options for the third one, 26, 26, and 26. We multiply them all together, and that's going to give us a total number, and it was 45 million.
45,000.
No, 45 million, no?
45,697,600.
La B, ¿cómo sería mi suegro que no? Espérate, güey.
Everybody good here?
Yes.
I think everybody's good here. Okay, now, for B, what's changing? Can anybody describe in their own words what has to change?
Digits can be repeated and letters also.
Right.
Nada se puede
Te
repetir.
tienes que ir restando.
Right, so let's think about what happens. Let's assume that our first letter, let's just put an A there. How is that going to change over here?
Va a ser 25.
Right, you have less options
24.
because now you can't pick A anymore. Right? Okay, so how many options do you have in your first panel?
Va a ser 26. Luego
26 options, right?
10, luego 9.
You're in your second space. How many options do you have? You still have all of your digits available. So the number of options is 10. However, in the third spot, you only have 9 options because you can't use whatever was in the second spot, you can't use it there. You have 9 options. And then 25 options in the fourth,
And then 24.
24, and 23. These are your options. When you multiply them together, what do you get?
32,292,000.
32 million,
292,000.
000.
Yes.
So you see that we lost 13 million. We lost 13 million combinations because we couldn't repeat these letters.
¿Y esa es una población de Texas o sí?
I don't know what the population of Texas is, but the U.S. has like 400 million. I don't think Texas has this, but also not everybody in Texas has a car. There's a lot of like underage people,
Homeless people.
but yeah, yeah, that brings up a good point about like how many different possible cars you can register in Texas, assuming these constraints.
No, pues sí, eso está fácil.
Y esto ya es lo dificilillo del.
No, we haven't looked at permutations. So, what happened here? I'm gonna cut the video there, actually.
Bye.